Welcome back to the MultiSim 1 tutorial, and we're building a guitar pedal. And it's a good time to save. We just kind of started the circuit off, but it's always good to save regularly. I want to move the circuit over a little bit. The save button's up here under the checkerboard, so let's save our circuit. And once we're done with that, we're going to add a transistor. The transistor is an NPN type, and it's going to show you what's going on here. It's going to be, the base of it's going to be connected to the output of that capacitor there. So you go down to the palette over here and you find a transistor. It's the first transistor. It's an NPN. It's a BJT. And we're going to put it so that the base is right in line there with the capacitor. So I'll put it maybe, right there. That'll probably be fine. It didn't do that. Let's try that again. For whatever reason, it didn't work. Try again. There it is. And as I said a moment ago, hit J and let's connect the base of the transistor to this capacitor coming from the audio input from the guitar. So that's good. The next thing to do stop. I'm having problems with my trackball. There we go. So the emitter of the transistor, the bottom of it, needs to connect to ground. So same thing, I'll press J to make a junction there and junction it to the ground. So now we've got 2 of the 3 leads of the transistor connected. The third lead is the collector up at the top, and it is going to be connected to the top of the 9-volt battery, the positive side of the 9-volt battery, but it's going to go through a resistor, a 10 kilo ohm resistor. So I'm going to press the R button so I can get myself a nice resistor, and I'll put it up here, and I'm going to rotate it, and I'm going to create a junction between the two. So junction and junction, and I'm going to take the top of that, make a right angle here. Clicking makes a nice right angle, and it actually made a nice right angle there without me clicking for the second right angle there. And we have now connected the 9-volt battery to a resistor. The resistor needs a 10 to be 10,000 ohms. So I'm going to click in here. I could type 10,000, or I could hit the order of magnitude button. Boom, 10K. There we go. And this resistor here is going to limit the amount of current traveling from the 9-volt battery, which is good. It's also going to create a voltage divider with the next thing we're going to do, which is create this path for bias. We need another resistor, so put it somewhere around here, and it's horizontal. And this guy's going to be a 10 million ohm resistor. It's pretty tiny resistor. We're going to we'll double click on that, and come on, buddy, you can do it. And we'll make that 10 mega ohm, which is, come on, you can work. It's being weird. There we go. It's 10 mega ohm. And I'm going to create a junction here and connect that to the bottom of the other resistor. We now have a voltage divider, and this guy is going to connect to the path right after the capacitor. So we now have an interesting circuit here. The 9-volt battery is going to provide DC current, which is going to travel through the resistor and from the collector through the emitter to ground. Now, a little bit of that, this voltage, a little bit of current, a very small amount of current, also will travel through the bias resistor and go to the base, and go from the base to the emitter to ground. So there's a tiny current path here going on, and there's a large current path here. Now this tiny current puts a voltage at the base, and that gets the NPN junction, that gets the transistor to work. That starts the flow of electrons. You need this other small voltage to make the larger current flow. So this guy, the bias, turns on the transistor. Now the analog audio coming from our guitar over here, it comes in and it modulates, it turns up or down the amount of DC current here. This creates an audio output, a much more amplified audio output, which is up here at the collector. So this becomes your audio output, and this becomes your audio input. Your audio input is the AC, but your audio output is actually AC as well, but it's been created from this 9-volt power source. Okay, so this is a good place to stop. We'll move on in a second, and we'll add some other features, but this is a good place right here. Keep the video nice and short. All right, have a